to Grade 4, Chapter 12, Functions and Graphing. Now, you might be thinking, functions, ooh, cool word, but we'll be learning about that later. So first, before we get to all the fancy and cool stuff, we have to teach you in Section 1 about negative numbers. So on the number line, numbers become greater as you move from left to right. Numbers greater than 0 are positive numbers. Numbers less than 0 are negative numbers. So negative is anything less than 0. 2 and 6 are positive numbers, and that little minus-like sign is, well, negative. Negative 8 and negative 5 are negative numbers. Identify each number as positive or negative. So question 1, does it have that little dash minus thingy? Yes, it does. So it's a negative number. Question number 2, 4. Does it have that little minus negative dash thingy? No. So it's a positive number. It doesn't have that little dash minus sign thing, so it's still positive. Now this one, it has that sign, so it's negative. When a number has that sign, it means that they are less than 0, so they are negative. Write the number that represents each situation. Below sea level. Well, let's pretend this is sea level, and sea level is 0. Above sea level and below sea level. So if you're below 0, what would you be? Negative. So it was now 14 feet above ground. Now let's pretend the ground is 0. And if you're above ground, then are you greater than 0 or less than 0? Greater than 0. So would that be positive or negative? Positive. So that would be 14. 7. Loss of 18 pounds. Let's say that you weighed 100 pounds and you lose 18 of them. Would your number be going away from 0 or would it be going down towards 0? If you lose 18 pounds, the number goes down, right? So loss of 18 pounds would be negative 18. Gain of 3 kilograms. So when you're gaining, it usually means that it is positive. Because if it's a positive number, you are going away from the 0. And if you're a negative number, then you're becoming more towards the 0. So that would be positive 3 without the sign. Profit of $74. So profit is the amount of money you get. So a profit of $74. What do you think about when you think about the word earn? Well, there's more money. So it would be 74 with no negative sign. 10 degrees above 0. Now I'm sure we've all seen the weather before, and if they say it's 10 degrees, then it means it's 10 degrees above 0. So do they say it's negative 10 or minus 10? No. So that would just be 10. 5 degrees below 0. I'm sure we've also heard the radio station tell us that it's negative 5 or it's minus 5 today with freezing rain. So minus 5 or negative 5. Loss of 5 ounces. Now before we talked about loss of 18 pounds. So ounces is also another thing like that. So if you're losing 5, then it's a negative. That's done. So now we're going to do some of the more serious stuff. Find points on a grid. This grid over here shows the location of rides in an amusement park. Where is the space ride located? So we go down, and you see the space ride is down here. So we start at 0, we go right to 1, and then we go up 2. So that results in the location of the space ride being written as an ordered pair 1 bracket 2. So in the ordered pair, the first number tells you how far to go to the right, if it's positive, but we're going to talk about the negative ones later. The second number tells you how far to go up. So let's try this. 5, 1 is an ordered pair. So which ride do you find? So the first number is 5. We move 5 squares to the right. So let's see. 1, 2, 3, 4, 5. So the number 5 is here. And then 1, it tells us to move 1 up, which is here. Which ride do we find? We find the teacups ride. So we write teacups. Yay! Anyhow, so now we complete all these questions and using this grid. Start at 0, go right 8, and then go up 3. The ordered pair is bracket, 8, comma, something, and bracket. What is here? So the first number is how much we go right, and the second number is how much we go up. So we go right 8, and then how much do we go up? 3. So we write 3 here. What is here? Well, let's go to 8, which is here, and then let's go up 3, which is here. It's a scrambler. So we write scrambler. Now for question number 2. Start at 0, go right 4, and then go up 4. The ordered pair is bracket, something, comma, 4, and bracket. What is here? So the first number is how much we go right, right? Get the joke? So what is the number over here? If it's how much we go right and we write 4, then the number is 4. What is here? Well, let's do this. 4, and then we go up another 4, and then it's a log ride. So we write log ride. Number 3. Start at 0, go right 2, and then go up 8. The ordered pair is blank. What is here? So the first number, the ordered pair is always in brackets with a comma separating the first number and the second number. The first number is how much we go right. So the first number would be 2 in this case. And then we go up 8, and the second number is how much we go up. So that's 8 in this case. What is here? Now let's scroll back up, and then 2 is here, and then we go up 8. Oh, it's a sky ride. So we go down, and then we write sky ride. Question number 4. Start at 0, go right 6, go up 7. The ordered pair is blank. What is here? So brackets, comma separates first number and second number. First number is how much you go right, so 6. Second number is how much you go up, so 7. And so 6, 7. What is here? Well, 6 and 7. Here. Paddle boats. Paddle boats. Now we identify the ride that is located at each of these ordered pairs. So 5, 8. We go to 5, and then we go up 8, and then we see that it's the Ferris wheel. Now we write Ferris wheel. And there's 1, 6. So we go to 1, and then we go up 6, and there's the swings. Some people like to work this way, and some people like to work downwards. I'm more of a this way person, so anyhow. The next one is 2, 3. So 2 is here, and then we go up 3. It's shells. And then question number 9 is 6 and 4. So 6 is here, and then we go up 4, and that's the roller coaster. So roller coaster. And then we have 4, 6. Well, bracket 4, comma 6 in bracket. But we don't need to say it like that. So 4, and then 6 is tidal force. That's a strange way to name a ride, but alright. Finally, we have 8, 8. So 8 is here, and then we go up 8, and that's a carousel. Or the merry-go-round, as some people would prefer to call it. Alright, now we're done that question. We move on to the next part. We're actually done the section. Hooray, we're at section 3 now. So now we're finally at the graphing bit. Graph ordered pairs. So we know that an ordered pair is two numbers that say, well, first of all, the center point of a grid is 0, 0. So here. This point is also called the origin. Anyhow, the first number in the pair tells you where on the x-axis the point is. Now, the x-axis is the horizontal one. I'm going to label that right now, so yep, that's the x one. Now, usually you would label on the right side. This is how far left or right you go on the grid. Negative numbers are on the left side. Positive numbers are on the right side. Now, I know that before we told you that it's how far right you go, but if you think about it, if you're going a negative amount of steps somewhere, it's like walking backwards. The second number in the pair tells you where on the y-axis the point is, which is the vertical one. Now I'm just going to label the y-axis. Usually you label y on, well, the top. So this is how far up or down you need to go on the grid. Negative numbers go down and positive numbers go up. Now I know that before we said, well, that this second number tells you how much you go up. But again, if you're going a negative amount up, it's like going below sea level, which is negative. So, yeah, that makes sense too. Now, graph and label each point on the grid. So, we have number 1, point D, which is 5, 2. So we find 5, because it's positive, we know that it's on the right side, and it says right here, right? So 5 is here, and then it's 2. And since it's positive, we go up. So 5, 2 is here, and that's point B. And now we have point E, which is negative 2, 1. So we find negative 2 on the x-axis. Oh, we should label the x-axis first, and the y-axis. So we find negative 2, which is here, and then we find 1 on the y-axis, which is here. Now, this would be point E. We're on the third question. Point F is 2, 4. So we find 2 on the x-axis, because that's the first number, and then we find 4 on the y-axis. So this would be point F. Question number 4 tells us to find point G, which is negative 4, negative 5. So we find negative 4 on the x-axis, which is right here, and then we find negative 5 on the y-axis. That's point G. Point H is 3, negative 4. So we find 3 on the x-axis, and then we find 4 on the y-axis. Here. That would be point H. Point I, usually you don't label point I because it stands for something else, but we learned that in a later grade. Point I is 1, 0. So we find 1 on the x-axis, and then we find, well, 0 on the y-axis. And we don't go here because that would be 0, 0. So then we stay at 1, and then we go nowhere. So this is point I. Hooray! We're done that exercise. Find the length of a horizontal or vertical line segment formed by each set of ordered pairs. Now, if we're going to find diagonal lines, then that's a discussion for a later grade. So, negative 1, 1, and 5, 1. Now, as we can see, for this one, it would be a horizontal line because the y value is the same. See? So, x and y. And negative 1, 1 would be here, and positive 5, 1 would be here. See, it's a horizontal line. And now we count 1, 2, 3, 4, 5, 6. 6 units. And then we have 5, negative 2, and 5 and 5. So that would be a vertical line because the x value is the same. So 5, negative 2 is here. And then 5, 5 would be here. This line would be 1, 2, 3, 4, 5, 6, 7. 7 units. The next question asks for negative 3, 7 and 6, 7. So as I said, the y value is the same, so it would be a horizontal line. Negative 3, 7 is all the way up here, and 6, 7 is not on the grid. Well, that's kind of sad, but we can still count from negative 3 to 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units. Question number 10 asks for negative 2, 4, and negative 2, negative 3. And again, the x values are the same, so this will be a vertical line. Negative 2, 4 is here, and negative 2, negative 3 is here. 1, 2, 3, 4, 5, 6, 7. 7 units. Of course, for horizontal or vertical lines, we could just find the distance between the 2 points that aren't the same. Now you might be wondering, how do we find the distance between negative 2 and 5? Well, we know that the distance between 5 and 0 is, well, 5. And 0 and negative 2 is 2, and 5 plus 2 equals to 7. Of course, there's the easier way, which would just be 5 minus negative 2. But we haven't learned the addition and subtraction of integers, as we call this. Integers are negative or positive whole numbers. We're not going to use that way. Now, answer the following using a coordinate grid that has 4 quadrants. Rose traveled from negative 5, 1 to 4, negative 5 by first moving up or down and then left or right. Describe rows as movements. So we already have a coordinate grid that has 4 quadrants. Now, each one of these is, well, a quadrant. So yeah, we cleared the grid. So Rosa traveled from negative 5, 1, so negative 5 on x, 1 on y, which is here, to 4, negative 5. 4 on x and negative 5 on y, so there. By first moving up or down, and then left or right. Describe Rosa's movements. So she first moves up or down. She can't move up and then move anywhere because that's obviously not where she's going. So first she must move down. And then she moves right. Because if you move left, she's just getting further from her destination. Describe Rosa's movements. So she moves how many squares down? 6. And how many squares does she move? These squares are all units, by the way. How many squares does she move? Right. Well, 1, 2, 3, 4, 5. And 5 plus 4, 9. So Rosa's movements. Rosa moves 6 units down and 9 units right. Ta-da! Done. Now for the next question. Anyhow. Now we go on to the next question. Tim traveled from 4, negative 3 to 0, 2 by moving left or right, then up or down. Describe Tim's movements. So let's go on the grid. Tim went from 4, negative 3, so 4 on x, negative 3 on y here, and then to 0, 2. So 0 on x and 2 on y, which is here. By first moving left or right, so he moved horizontally first, and then he moved vertically. Alright, so if he moves to the right, he goes further from where he wants to go. So he moves to the left first. And then, if he goes down, he's also going further from where he wants to go, so he moves up. So that would be 4 squares left and 5 squares up. So Tim moves 4 units left and 5 units up. Now, Dan needs to put 6 cups of sea salt into the seawater tank. He has a 7-cup container and a 5-cup container. How can he use the containers to measure 6 cups? So step 1, understand the question. What do we know? And what is the question asking us to do? Well, we know that he has a 7-cup and a 5-cup container, and we know that he needs 6 cups of sea salt. And the question is asking us, how is this possible? So step 2, we make a plan. Well, we know that there's a 7-cup and there's a 5-cup. So if we pour 7 cups into the 5-cup, then there will be 2 cups left. And 6 is made out of 3 2s, or 6 divided by 2 equals to 3. So our plan is to use the difference between the 7 and 5 cups. All right. Now, step 3 is solve, carry out our plan. So, step 1, we fill in the 7-cup container, and then we have 7 cups of sea salt in the 7-cup container. And then we have 0 cups of sea salt in the 5-cup, and 0 cups of sea salt in the tank. And then we fill the 5-cup container from the 7-cup container. So the 7-cup container has 2 cups left, and the 5-cup container has 5 cups in it. And there's still no sea salt in the tank. Pour what is left in the 7-cup container into the tank. So there will be nothing left of the 7-cup container. There will still be 5 in the 5-cup. And then there will be 2 cups in the tank. And then, of course, we empty this out back into the sea salt bag. So we repeat steps 1 to 3. How much sea salt is in the tank now? 4 cups will be in the tank now, because then we add another 2 cups. And then we repeat steps 1 to 3 again, and we have 6 cups, because we add another 2 cups. We're done. So step 4. Is the solution reasonable? Well, it is. So we reread the problem, and we think, how can we check our answers? Well, since it's logical reasoning and it's asking us how, there will be many ways to actually do the question. And we read the question. Dan needs to put 6 cups of sea salt into the seawater tank. He has a 7-cup container and a 5-cup container. How can he use the containers to measure 6 cups? And we did find a way where he could measure the 6 cups with the 2 containers. So our process makes sense. And since our solution is our process, then our answer is, well, correct. Now let's do some practice problems using logical reasoning. A worker has a 4-gallon pail and a 9-gallon pail. How can he use them to fill a 10-gallon tank with water? Well, this is like the previous question. 9 minus 4 equals to 5. 10 divided by 5 equals to 2. He can use the difference to get 5 gallons. And then he repeats to get 10 gallons. So, that's done. Number 2. Marsha arrives at the theater 10 minutes before Sam. Sam arrives 20 minutes after Lynn. Paul arrives 10 minutes before Lynn. Lynn gets to the theater at 6:30 p.m. When do the others arrive at the theater? Well, logically, we know that Lynn arrives at 6:30. So we'll just use L for Lynn. And Paul arrives 10 minutes before Lynn. So Paul would be 6:20 because that's 10 minutes before 6:30. And Sam arrives 25 minutes after Lynn. Sam arrives 25 minutes after 6:30 would be 6:55. And Marsha arrives at the theater 10 minutes before Sam. So then Marsha arrives somewhere over here. And 10 minutes before Sam would be 6:45. Now, if you want to put this into a full sentence, it would be Paul arrives at 6:20, Marsha arrives at 6:45, and Sam arrives at 6:55. That's it. Now we move on to the next section. Alright, so section 5, we're finally going to teach you about functions like we promised in the title. So, the numbers in a function table relate to one another to form a pattern. So, if you think about it, it's really just a number pattern, except x, which is the value on the horizontal axis, is a term number. You know how there's terms in a pattern, like the first bit of a pattern, and then the second, and then the third, and then the fourth? Yeah. So x is really just a term number, and then y is the real pattern. Example, one number is 1 greater than 2 times a number. So the equation would be one number is always y, is 1 greater than 2 times, it would be x, a number. 1 greater than 2 times a number. So the equation is 2x plus 1, and if x equals to 1, then 2 times 1 plus 1, it would be 3. 2 times 2 plus 1 is 4. 2 times 3 plus 1 is 7. 2 times 4 plus 1 is 9. 2 times 5 plus 1 is 11. That's it. So in each case, you have to do the same thing to x to get y. Now let's do some practice problems. Complete each function table, then write an equation. So sometimes you can write the equation first. One number is 2 greater than another number, so the one number is always y, and then 2 greater than another number, so that would be x plus 2. Y equals x plus 2. That's your equation. Now let's complete this table. Y equals to x plus 2, x equals to 1, 1 plus 2 equals to 3. That makes sense. Y equals to 2, 2 plus 2 equals to 4. That makes sense. So 3 plus 2 is 5. 4 plus 2 is 6. 5 plus 2 is 7. We've completed the table. Now we move on to the next table. One number is 4 times another number. So one number, y, is equal to 4 times another number, x. So let's see if it works. X equals to 1, y equals to 4. 1 times 4 equals to 4. So 4 equals 4, it works. And then x equals to 2, 2 times 4 is 8, y equals to 8, that works. Now we continue. 3 times 4 equals to 12, 4 times 4 equals to 16, and 5 times 4 equals to 20. Now, question number 3. One number, y, is 5 less, so minus 5, than another number. Y equals to x minus 5. Does it make sense in the table? X equals to 10, 10 minus 5 equals to 5, y equals to 5. It makes sense. So we continue. X equals to 9, 9 minus 5 is 4, y equals to 4, x equals to 8, 8 minus 5 is 3, y equals to 3, x equals to 7, 7 minus 5 equals to 2, y equals to 2, x equals to 6, 6 minus 5 is 1, y equals to 1. We're completed that table. And we got the equation too. One number is 1 less than 2 times a number. So let's see if it makes sense. When x equals to 1, 2 times 1 equals to 2, but 2 minus 1 equals to 1. So y equals to 1, y equals to 1. It makes sense. So now we continue. X equals to 2, 2 times 2 equals to 4, and 4 minus 1 equals to 3. X equals to 3, 3 times 2 equals to 6, 6 minus 1 equals to 5, y equals to 5. X equals to 4, 4 times 2 equals to 8, 8 minus 1 equals to 7, y equals to 7. X equals to 5, 5 times 2 equals to 10, 10 minus 1 equals to 9. Hooray, we're done. So, what do we get when we combine graphing and functions? Well, we get section number 6, graph functions. You can use the numbers in a function table to graph an equation. Graph the function y equals to 2x plus 1. The values in the table form ordered pairs. You can graph these ordered pairs. So this is a table, it's already given to you. So we have 1, 3, we get the point over here. 2, 5, we get the point over here. 3, 7, we get the point over here. 4, 9, we get the point over here. And 5, 11, we get the point over here. So then we graph it like this. But one thing that is wrong about this graph is that we need to add continuation signals, because it never says that x can't be 0, or x can't be 6, or x can't be infinity. So the continuation signals would be arrows on each side. This is a line. A line with circles on each side is a line segment, because a line segment starts and finishes at certain points. Now, you might be wondering, what if, now let me make more space here, what if there's a point at one end and then just a continuation line? Well, that's called a ray. Got it? So we move on to the questions. Complete each table. Write the ordered pairs and graph the functions. So y equals to 2x. X equals to 0. 2 times 0 equals to 0. X equals to 1. 2 times 1 equals to 2. 2 times 2 equals to 4, 2 times 3 equals to 6, and 2 times 4 equals to 8. So we're just going to write that. Done. So the ordered pairs that we have are 0, 0, 1, 2, 2, 4, 3, 6, and 4, 8. So let's graph these. 0, 0 is here, and 1, 2 is here, 2, 4 is around here, 3, 6 is around here, 4, 8 is around here. Now I'm just going to tell you that I don't have a ruler, so this will look like a very unstraight line. Trust me, guys, get a piece of paper and try to draw a line connecting specific points. And make sure that the line is straight. It's harder than it sounds. So now, we connect these, and then we draw the continuation thing on both ends. Yay, we're done. Now we move on to question number 2. So y equals to 2x plus 2. Let's plug in the x values. X equals to 0. 2 times 0 equals to 0. Plus 2, 0 plus 2 equals to 2. So y equals to 2. 2 times the 1 is 2. Plus 2 equals to 4. 4 equals to y. Y equals to 4. 2 times 2 is equal to 4. Plus 2 equals to 6. Y equals to 6. 2 times 3 equals to 6, plus 2 equals to 8. 2 times 4 equals to 8, plus 2 equals to 10. And we just put that. Now, we find these ordered pairs, and then we graph them. So 0, 2 is around here. 1, 4 would be around here. 2, 6 would be around here. 3, 8 would be around here. 4, 10 would be around here. This is why graphing paper is so much better, because you can actually see where the grid lines meet and make a more accurate point. So let's connect these now. And draw the continuation signals. Yay! We're done question number 2. Now we have question numbers 3 and 4. So y equals to x plus 5. when x equals to 0, 0 plus 5 equals to, well, 5. And since x goes up in increments of 1, then the y value would also go up in increments of 1 because the x isn't multiplied by anything. See? If x is equals to 1, then 1 plus 5 would equal to 6, 2 plus 5 would equal to 7, 3 plus 5 would equal to 8, 4 plus 5 would equal to 9. Easy. Now, we graph the points. 0, 5 is around here, 1, 6 is around here, 2, 7 is maybe there, 3, 8, 4, 9. And we'll draw the line connecting all of those and do the continuation signal. Now we move on to question number 4. Y equals to 3x. So x equals to 0. 3 times 0 equals to 0. This question is like your 3 times tables out again. So 1 times 3 equals to 3, 2 times 3 equals to 6, 3 times 3 equals to 9, 3 times 4 equals to 12. Remember your multiplication tables? Functions and everything else in math use multiplication tables a lot, which is why they are great to remember. Now let's graph this. 0, 0 would be here. 1, 3 would be around here. 2, 6 would be maybe there. 3, 9 would be there? Yeah. 4, 12 would be off our current grid, but it's around there. So now that we're done that, we're connecting this line in a very, oh, that's a shaky line. And then we'll draw the continuation signals. Question number 5. And nope, that's not the last question. You thought it was done? No, it wasn't. Y equals to 3x plus 3. X equals to 0, 0 plus 3, 3. Now, this is also a lot like your 3 times tables, except you just add 3. So, since we know that if it was normal, this would be 0, this would be 3, this would be 6, this would be 9, this would be 12. Then we just add 3 to all of them. So 3, 6, 9, 12, 15. So, let's graph it. 0, 3 is around, 1, 6 would be around there, 2, 9 would be around there, and I'm not even going to bother to draw the rest of the thing because it goes way off the charts. And if we can draw a completely straight line, well, then we would know where it would meet. Question number 6. It's the last question. We're almost done, guys. Hold on. So, y equals to 4x. Does this look familiar? Does it? It really does. It's your 4's timetables, guys. Anyhow, 0 times 4, we all know, is 0. 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. So 0, 0 is here, 1, 4 is here, 2, 8 is here, 3, 12 is here, and I'm not going to write that one because it would be too off the charts. We connect the lines, and that would be around what it looks like. Please use a ruler when you're doing this activity, guys. Do yourselves a favor, use ruler, use graph paper if there isn't a graph already given to you. Just do yourself a favor and use a ruler. And pencil. Please do math in pencil. Doing math in pen is not a good idea. And we're at the last section of the chapter. Hooray! You've lasted this long, but it's not time to slack off yet. So, problem solving again. A landscape contractor is planting shrubs. She places each shrub 3 feet apart, a distance of 20 yards. She places the first shrub 3 feet from the starting point. How many shrubs does she use? So what do you know? Well, the distance between shrubs is 3 feet. And it's over a distance of 20 yards. We also know from, was it grade 3 or grade 4? From a previous grade that a yard is equal to 3 feet. So the first shrub is also placed 3 feet from the starting point. What do we want to know? How many shrubs does she use? So step 2, plan. We can choose a strategy. So we can use logical reasoning in which we divide, or we could draw it. Now drawing would be a lot more time consuming and you would probably want a ruler. So I don't recommend drawing. But here's how you would do drawing. You show a 60-foot distance, or you could just do 20 yards because we know that a yard is 3 feet. Count by threes and then add tick marks. So you count the tick marks from 3 to 60. We don't count 0 because remember she places the first shrub 3 feet from the starting point. So how many tick marks is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. So 20 shrubs are used. Or we can use logical reasoning. So the distance is 60 feet. There will be 1 shrub every 3 feet. So write a division equation. 60 divided by 3 equals 20. 20 shrubs are used. There's a problem with this because she starts 3 feet from the starting point. That's why this solution works. But if she had put a tree at the starting point, then think about it like this. There's a piece of land. You're trying to divide it into 2 pieces. If you don't need the poles at the end, then you only have 1 pole that you need. Or 1 place that you need to divide. But if you need 2, then only one of the ends would have 1. But if both ends have 1, then you would need 3 when you're dividing it into 2 pieces. So if there was a shrub at the starting point, you would need to do this, and then you would need to add 1. But thankfully, there isn't. So we don't need to add 1. Step 4, check. Is the solution reasonable? We reread the problem. And does our answer make sense? Which method do you prefer? That is your own personal preference. Personally, I like using logical reasoning better because it's quicker and you don't need to draw this entire thing. However, if you like to draw, that's your choice. Let's reread the question. A landscape contractor is planting shrubs. She places each shrub 3 feet apart over a distance of 20 yards. She places the first shrub 3 feet from the starting point. How many shrubs does she use? Well, we got our facts right, and our answer works with the facts. So our answer makes sense. Yes. Oh, by the way, since we know that 3 feet is equal to 1, we could also simplify it and do 20 divided by 1 equals to 20. That works too. Practice problem number 1. The Parks Department builds 5 rows of stands next to a baseball field. Each row is 20 feet long. How many 10-foot long boards did they need to build the stands? So there's 5 rows, and each row is 20 feet. So that's 5 times 20 is 100 feet in total. How many 10-foot long boards do they need? 100 divided by 10 equals to 10. So they needed 10 boards. Now you might draw it out. 5 rows. And each of these is 20 feet. There's 10 foot long, so each of these would have 2, and then you count. But honestly, it's easier just to think about it and do it all in your head instead of drawing it out, since the reasoning behind all of these is the same. Question number 2. Ed has 4 packs of sports stickers. There are 24 stickers in each pack. He divides the stickers among 3 friends. How many stickers does each friend get? So if you are going to draw this out, you are going to have to draw 4 packs of 24 stickers, and that would be 96 stickers. That is going to take a very, very long time to draw. So do yourself a favor and just do some good old-fashioned multiplication. He divides the stickers amongst 3 friends. How many stickers does each friend get? Then you're going to have to make sure that you circle 3 portions with an equal amount of stickers if you're drawing this. So do yourself another favor and do some good old-fashioned division. Now you may be wondering, how can I do division for this? Well, you'd use long division. 3, how many times does 3 go into 9? Well, 3. So then that would be 9 down here, and then 9 minus 9 equals to 0, and then you get 0, 6. And how many times does 3 go into 6? 2. And then that would be 6. Each friend gets 32 stickers. Done! We're done the chapter. Chapter 12 is done. Give yourselves a pat on the back.